Okay, number 36 from Connect. You're asked to calculate a KB, and you are given that the pH is 9.48. Okay, from your, you're also told that the concentration of the weak base is 0.16 molar, weak base. Okay, from the ice table, we know that if we were to do an ice table for a weak base, it would look like this, that the KB is equal to x squared divided by the concentration of the weak base minus x. And now usually when we do an ice table, we're solving for x so that we can calculate the pH. And when we do that, we eliminate this x to avoid quadratic. Okay? Well, what is x? Since you're using a KB, you know that x is equal to the concentration of the hydroxide ion. You can get x from this information because if the pH is 19.48, then 14 minus that is the pOH. So the pOH is 4.52. And then the pOH, the inverse log of that will give us the concentration of the hydroxide ion. Okay, so that means that X, which is the hydroxide ion concentration, is 3.02 times 10 to the minus 5, and that's molar, because that's what X is, the concentration of the hydroxide when we're using a KB. So now we can solve for KB because we know X is 3.02 times 10 to the minus 5 divided by the 0.16 molar, see that's coming from here, minus 3.02 times 10 to the minus 5. I get 5.7 times 10 to the minus 9 for the KB. Now, I would get this answer whether I used the X or not. And the reason I get that answer whether I use the X or not is because this is less than 5% ionized. Remember, I just realized I forgot to put that I squared this on the top, but I did square it. Remember percent ionization, you'd say that 3.02 times 10 to the minus 5, because that's how much ionized, divided by 1.6. And as long as that's less than 5%, multiply it by 100. And I mean, it is. It's like, I pushed something wrong on my calculator. It's like 0.01%. So it doesn't matter that you include this, but you can include it.